Hi there. Welcome to the Core Data tutorial. Uh, this tutorial is designed to basically give you a really brief overview of core data. Core data, just like SQLite on Android, is a hard concept to teach because, one, if you teach the concepts, there's tons of concepts and tons of different frameworks and things that, or classes, libraries, whatever else that go into it. So that's a huge pile of things to learn, uh, and to give a full solution instead is equally difficult. So the purpose of this tutorial is really just to sort of get your feet wet and get something working. Because one great thing about core data is it is very possible to get a solution, an app with persistent data up and running very quickly. So that's the purpose of this tutorial. I'll try to include caveats if we're doing something that is bad practice for the sake of the demonstration, but hopefully this should really get your feet wet and get you ready to dive in deeper to core data. So the app we'll be making today is similar to the last app if you've watched the table views and storyboards tutorial. Um, and actually we'll be using a lot of the stuff from that tutorial and probably blowing through it. So if you haven't watched that tutorial yet, I definitely recommend it. Otherwise you might be a little confused when we go screaming through a couple of the concepts covered there. So here's the app we'll be making today. It is, again, a to-do list application. This one's a little less useful because the core data stuff, it turns out, is actually a little complicated. So here, instead of I don't remember what we did last time. I think it was per day or something like that. But here we have a list screen where we have lists of tasks to do. By clicking the plus button here, we can add lists. You'll see they come in with a nice animation. I guess the most unuseful part about this app is the fact that we can't change the names of the lists. That, it turns out, is a bunch of infrastructure that just takes a lot of time to demonstrate but doesn't actually add much. So more useful, we can sort of drill down into the list here, add a couple of tasks. Now these tasks we actually can change the name of. So use one of the examples from last time. We can save this task and see that it says learn to program here now. And actually I haven't tried this yet, so fingers crossed. We should be able to not actually save. Yep, by just backing out of it. So the save button is actually what performs the save. And this won't actually look too different from the app we did last time. We can also delete just like last time. Except for the fact that upon exiting the app, we can kill it here, go back into the app, and actually have data here, something that wasn't available last time. So that's the whole point of this tutorial, is to be able to persist data across app launches. It seems like a simple thing, but actually requires a lot of infrastructure. So let's get started. I'm going to start a new project in Xcode. This will be an empty application. I picked this because it has this option right here to automatically use core data. That actually generates a lot of the built-in methods we need to get started. So we will actually have to do a little bit of work getting the storyboard and how the app is glued together set up, but that's stuff we're already familiar with, so no sweat. For the product name, let's call this task lists. Class prefix TL. I've done this before, so a lot of this stuff will be filled in already. It's an iPhone app. We will make sure we have use core data checked. Make sure include unit tests is unchecked because we will not do anything with unit tests today. And automatic ref counting should definitely be checked because I will not be teaching you anything about memory management today. Company identifier, edu.roseholman here. Use whatever you'd like. I'll just make it on the desktop here. You might want to create a local Git repository if you plan on saving this, but I won't be, so we'll just blow through it here. Alright, and here we are. Now, I don't think I've recorded a demonstration with an empty application before, so let's take a quick look to see what it gives us, just so we're not lost from the get-go. It doesn't give us much, to be honest. An app delegate here, which has a few extra properties we'll talk about in just a second. These are the core data methods. Implementation file here. This very specific core data file, and that's it. No storyboard, no nothing. So, first order of business is to create a storyboard. User interface here, storyboard. It'll be an iPhone for the device family. This is an iPhone app. I'll call it TL main storyboard. Usually just the classes are prefixed with the two-letter prefix. I tend to prefix just about all of my files, especially the ones that get compiled or interpreted into code with the two-letter prefix. It's just a habit. You can do whatever you'd like. So here's our main storyboard now. Before we go any further and before I forget, the default way an empty application works is it actually creates a new window when the app launches, makes it a white background color, makes it visible, and then returns successful from this did finish launching with options. It turns out this will actually prevent our storyboard from ever getting used, so first order of business is delete everything before the return statement. We also need to hook up our storyboard in the project itself. Here under iPhone, iPod deployment info, main storyboard, TL main storyboard. That's it. Now our storyboard's hooked up. So if you remember from the app I demoed, there are, I think, 3 different table view controllers. So let's throw this on the storyboard now. The plan here is we'll get all the stuff we already know out of the way pretty quickly, setting up the view controllers and whatever else. That way we have some infrastructure set up that we can easily jump into core data without having to monkey around with a bunch of other stuff all the time in the meantime. Alright. So we're also going to use a navigation controller, so we'll select the first one here and embed it in a navigation controller, just like last time. Give this a title of lists. It'll just have one type of cell, so we'll just use this right here. Do a push segue. Call this list contents. This will be where our tasks are actually listed. And again, we'll just have one type of cell in here, so one more segue, push into task details. Alright. Let's go through and fix a couple of these up here. Let's see. This will be a basic style. Let's say, just so we know what goes there. We'll give it a reuse identifier. Remember, we have to give it these so that we can actually use these cells. Just call it list cell. In a real app, you probably have a little more complex name so they don't run into each other, but they're actually only shared within a scope of a view controller, so it's no big deal. I usually make mine a little more specific, whatever. We'll do the same thing for this cell here. Basic type. We'll call this task details. Give it a reuse identifier of task cell. And then here in task details, we're going to do what we did last time by not actually using the table view for its intended purpose and instead making it just kind of a holder for our controls. So switch it to static cells type, switch it to grouped style, delete these couple of cells down here, select a section by clicking in between the cell and the top. We'll call this description. And here we'll actually put a text field, kind of like we did last time. Just use the HIG blue guidelines here to properly stretch it so that it fills up the right portion of the cell. Once we've got it drawn on there, give it the dotted line border style, which is no border style. Let's switch the font to bold too. I don't really know why, just because. Alright, So this is actually a lot of our app. Before we go into core data, let's go ahead and stub out sort of the code part of all of this. So we're going to make 3 view controller subclasses up here in Cocoa Touch. We'll do Objective-C class. They'll actually be table view controller subclasses, so make sure that's filled in. Make sure both of these boxes are unchecked. This is not for iPad, and because we're using a storyboard, we don't need zibs. So let's call this one the list view controller. It's the list of lists, so you can come up with a better name if you'd like, but I'm sticking with this one. Okay, so there's one of our view controllers. Make another one here. Let's call this one task list view controller. And one more, task detail. Let's jump straight into our task detail before we forget, and delete all the table view delegate and data source methods, because remember, by implementing these we are sort of signaling to the table view that we intend on providing it dynamic data, which kind of undoes our static fields or our static cells that we've set in the storyboard. So delete all the way up to should auto rotate to interface orientation. All right. A couple more things we should do here before we dive in. We'll need to add a couple of buttons to our storyboard. Bar button items, to be specific. And these will be the add buttons. And then, in the case of the task detail, the save button. So for our first 2 view controllers here, select the bar button item we just dropped in and use the add identifier. Using these identifiers is good because if you ever internationalize or localize your app, these get automatically converted. As far as I know, at least. Obviously, the plus is not language dependent. Here we'll use task details. Here we'll use the save identifier. This is something that hopefully would be translated properly based on the locale. And you can see that by using the save identifier, we automatically have a done style bar button item here, which, again, you just get a lot of stuff for free by using those built-in identifiers. So what we want to hook up, but not necessarily implement right now, is the actions that each of these buttons call. So do that real quick here. You'll notice I'm jumping into the implementation file here instead of what we typically do, which is add a method here in the header file. Because we won't be calling this from anywhere else, Xcode currently, and by this I take it to be a suggested pattern, gives us a private category at the top of our implementation files where we can add things like actions, IB outlet properties, etc. that won't kind of clutter up the API for our class, but will be exposed through Interface Builder. So here we'll make an IB action. This is in our list view controller, so we'll call it add list. We'll drop in an empty implementation here. Put a to-do in there so we don't forget it. Do the same thing for task list. Except add task here, obviously. Same thing, empty implementation. And if it's a little confusing, it drops in void here. That's because IB action, I think, is just defined to be void, like directly defined to be void. Actually, might be able to find that out really quickly. Oh, maybe not. it's really just like IB outlet, I think is also defined to be void. They're just used to signal to the compiler and to Xcode itself what things need to be exposed in Interface Builder. They don't actually have any programmatic significance that I know of. So when we actually implement it, there's no need to call it an IB action here. You could, no harm. So we'll mark this as to do as well. One last one here. This is where the save IB action will be here in task detail. Same thing, we'll just add to the bottom here. Okie doke. So the reason I did this right now is so that we can hook them up here in the storyboard before we forget about it. I'd say the #1 waste of time that I've ever spent is looking for things that aren't hooked up, and that's kind of the most common gotcha for iOS programming, is not hooking things up in Interface Builder. And also, not marking things as their proper class. So you can see we just stuck this stuff together in the storyboard. It has no idea that this should be our list view controller, so we have to type that in here. And after we type that in, we can use our holding down control to drag from the button up into the status bar, which is the view controller itself. We can make it call the add list action. Do the same thing here for our task list. This completion right here is case sensitive, I think, which bothers me, but if you're having problems with it popping up, that could be it. One more for our task details. So we'll call the save IB action. Okay, now we've got all this hooked up. We should be more or less ready to go. Let's actually name the segues before we go to, just because. Actually, no, let's wait on that. That way we can copy and paste it when the time comes. Alright, so this should look really familiar. We did this last time. Just a bunch of table views, and eventually a way to edit the data. So now it's time to talk about core data. First, let's jump out into the app delegate here. This is the code that's been generated for us. Again, this is not going to provide you with a huge understanding of core data, but I would like to prepare you to be able to sort of continue your research on your own. So we've got 3 properties here, and then 2 methods. One of them is basically a property, and I'm not sure why it's not considered a property. So let's go through them one by one and just talk about what they are. The managed object context here, this is sort of your grand gateway into saving objects. Every object that you have that is managed by core data, they're each called a managed object, hence the name, the context. Each one of those objects belongs to a context, and that context is responsible for deleting them, saving them, and sort of propagating those changes down to the file system. In our case, we will only have one manage object context. Oftentimes you need to have more though. They are not thread safe, so you actually need to create a new one every time you operate in the background or do anything that might not be operating on the main thread, basically. So this is the object we'll be using the most. The manage object model, I would say, is exactly the opposite. It's the object we use the least. Often in my apps, I will make this a private property because there isn't much use, and nothing else will ever access this object. This is basically the sort of schema for our manage objects, and it basically opens a file on the file system and just hooks it up to an actual object in the code. And the only thing that uses that is this third property, the persistent store coordinator. This is kind of the big adapter between the files that are actually stored in the phone and the way those are managed and your application and your code. So this persistent store coordinator hooks up to the manage object context. And actually, to make a new manage object context, you just create one of these with a no arguments initializer and set its persistent store coordinator. So this is sort of the big important glue that basically manages the files on the file system and makes sure everything's hooked up properly. The thing we'll be interacting with pretty much exclusively in this tutorial is the context, but just so you kind of have an idea of how these work. Then we've got save context here. I don't know why this is included by default. I've never ever used it, but I guess some people would. This basically just calls the save method on the manage object context, which you can very easily just get the manage object context and call save on it. So I'm not sure exactly why it's there. And then the application document directory is basically a file URL to the place on the phone where this application is allowed to store its files. This is how the manage object model finds its sort of base file that it builds its model from. So hopefully that wasn't too much too fast, but that's kind of just an overview of how this all works. That way at least hopefully we can understand as we go through the app how it all sort of fits together. We can see here the implementations of these are usually pretty simple. They have tons of code in them in some cases, or tons of comments rather, in some cases. Specifically for the persistent store coordinator, these are all the property methods, and in each case it kind of checks to see if it exists already, and if not, creates a new one. This is code that you can look through in your own case, but I won't really go through in person. One thing to note, we actually do use SQLite here. So if you're running on the emulator, I won't show you here, but you can Google it and figure it out. You can actually browse and find that SQLite database and explore it yourself. It's not that interesting, but it is actually backed by SQLite. Though, again, we're using a pretty abstracted API, so it could be anything really. All of this comment is telling you about something that we won't cover at all in this tutorial, and that is the sort of upgrading from one version of your model to the next. Let's say you've got a bunch of different types of objects and you either edit them or add new ones. If these changes are complex enough, you will need to actually define a way to upgrade from an old version of the app to the new version. We will only be doing one version of the app here, and this information should point you in the right direction. The only thing you will be affected by is if you make a mistake while we're making our model and then run it again with a new model, it'll actually throw an error here, and you'll just need to uninstall the app and reinstall it because you haven't defined a specific way for it to upgrade. Okay, so now that we've spent quite a bit of time just talking about it, let's dig in. Here's probably the most fun part because it's really the easiest part of using core data, and then that's defining our model. So our entire model is defined in what looks like one file. It's actually a folder, but for the sake of Xcode, it is one file. And it's sort of almost an entire program in itself. It's got its own interface and everything here. This is where we define all our types of objects, their attributes, how they relate to each other, and we can even define fetch requests, which are kind of like queries, and configurations. We won't touch either of these here. We'll actually do that with code. Again, something to dig in yourself if you're interested. So for this project, we'll be basically having two types of objects, or entities as core data calls them. Lists, which contain tasks, and tasks themselves. So let's create those. Click the Add Entity button here. Pops up a new entity. And I also give these names prefixed with the two-letter acronym. Because when we actually create our code classes, having the names match automatically generates a properly named file. So you can do whatever you want. I'm just telling you this has a slight benefit. So let's call our list a TL task list. You can call it TL list or whatever you want. Let's make one other entity called TL task. Alright, so we've got two entities, and you can actually see by clicking down here, you actually have sort of a class diagram that you can explore. We'll take a look at that at the end. I don't find it that useful unless you have tons of things that you kind of want to check your work and make sure everything's hooked up properly. We've basically got two things we need to define on these objects: attributes and relationships. Fetch properties is a little more advanced topic. Again, you can look into that on your own. Attributes are basically, I guess you could call them primitive values that are associated with each entity. They aren't actually primitives, but they're flat values basically. So let's make a new one. For our task, we'll say it's got a details attribute. We call it description, but description is kind of a reserved property for the sort of toString value. So you can see we actually have a bunch of data types here that we can choose from. This does seem kind of limiting, but it turns out you can stuff anything you want into here. Binary data, you can serialize any object in the world and stuff into there. String, same thing. You could basically turn everything into base 64 encoded string and dump it in there. This is not meant to limit you. It's just meant to help you properly choose the correct SQLite data type or backing database data type. In this case, they match up pretty nicely with what we want to do. So here we'll just use string because details is just text. And one other thing we want, we'll call it created, is a date, which is actually a date and a time that this object was created. This is actually how we'll end up sorting the data. So even though it won't be displayed to the user, we do need to store it. We'll actually do the exact same thing for the task list. We'll call it title. Maybe it makes more sense. String type and created, which will be date type. All right. You can see these attributes are reflected over here in this sort of class diagram. Now we need to relate them to one another. So we do that in this relationships panel here. Let's select tasks first. Give it a new relationship. So from the task, the relationship will be called list, as in this is this task's list. It'll be a task list object, and we don't have any options for our inverse right now. Basically, all the relationships that we do in core data are meant to be, and core data asks you to make them two-way relationships. That is, from one object, you can traverse either way. So this task will have a list, and the list will have tasks. This actually helps core data automatically hook things up, so we don't have to set both when we're actually creating the objects. So we'll go over to task list here. Do the same thing. We'll call this tasks. It'll be destination of task, and now by hooking up the inverse to the list relationship, you can actually see if we switch back to tasks, its inverse has been hooked up as well. Again, this just lets core data know kind of what our intention is, so it can populate the information without us having to set the relationship on both sides, which is really nice when you're actually writing code. One last thing we need to do, from task list here, we want to make this relationship a too-many relationship, and this is in this last tab here. So we'll mark it as too-many, which means instead of just having one task, we can actually have many tasks. This kind of fundamentally changes how the database represents the data, and how basically core data handles all of it. We can also have this option of ordered. As of the time of this recording, there are actually some bugs with that where the methods that need to be called aren't actually generated, and we'll actually be using a different way of sorting them. So we will leave that unchecked for now. You may check into this and catch up on Apple bugs before you do so, but this is a potentially useful option here that we are not taking advantage of. Okay, so we've got these two lined out. Again, it's pretty simple, and you can see there's an arrow here connecting them now. The two arrows for the many relationship here. The work we just did is very simple, and it is pretty fun to kind of, graphically design your model objects. So here we kind of transition to actual code. We first highlight these two entities, and we'll click Editor, Create NS Manage Object Subclass. This is sort of the big magical step. Hit Create here. You'll see it actually generated two whole classes for us. with a pretty familiar set of properties here: details, created, and list. And then in this case, title, created, and tasks. You can actually see here it's also generated a category for adding task objects, removing task objects, and doing the same thing in plural form. So this is sort of the way that we integrate what we just did in that designer with our code. It turns out whenever you make changes here, you actually either have to completely regenerate these, so if you made changes to them, you have to sort of save off those changes or copy and paste them somewhere else and then put them back into the new versions, or sort of by hand know what the data types are to add them in. I guess that can be tricky only in the case where you're using booleans or numbers, because actually everything gets represented as an NS number, but you can cover that on your own. We won't actually be using any number types here. So we've got our two types of model objects created here. We shouldn't have to do anything, and you can see actually the implementations for these. They use the dynamic keyword here instead of synthesize. This basically means this will be implemented by something else, in this case the core data framework, so we don't actually have to see the implementation for any of these properties. So we've got our model object created. It's about time we actually started doing something useful. So let's jump over to our list view controller and try to do something useful. The first thing we should do is make a new property. I'm doing this here in the private category. This will be a non-atomic strong category property, and it will be an array of lists. We'll make sure we synthesize that property here. And this will be actually where we store our loaded lists, which means we can actually delete this init with style here. Don't use that. And here in view did load, we'll put a to do in here, load lists. So before we go any further, let's go ahead and implement these table view, data source, and delegate methods. These are useful for basically just hooking up the glue for how it displays things. We'll import here at the top before we forget the task list. So let's implement these. Number of sections in table view. Well, that's always going to be 1. Easy. Number of rows in section. Well, there's only one section, so we don't have to care what section it is. This will just be our number of lists. Again, easy. And then cell for row at index path. We'll use their boilerplate stuff here, except we'll change their cell identifier to list cell. And then right here we'll need to configure the cell. We'll first figure out which list we're talking about. And we'll do that by saying self.lists object at index self.tableview index path for selected row row. So basically look at our table view, find the wrapper object that basically just represents which row is selected, but it includes section information, and then pull off just the row value. So that'll be our current list. And then we'll just say cell.textLabel.text equals current list title. And that's all we need to do. Now basically whenever a list needs to be transformed into cell form, the only thing that needs to be transitioned is its title, so that's all we need. So now for the kind of new part. here, well, let's do this first. We need to load the lists. And this is kind of a big concept. Basically, we need to ask the manage object context, which is, remember, our gateway into sort of all stored data. We need to ask it to retrieve for us all of the stored lists. So we do that through a fetch request. So we'll say ns fetch request is what the class is called. We're going to make a new one. And there's a static initializer here. Fetch request with entity name. Now this should just be the string that is the name of the class in our data model. Because we used our two-letter prefix, TL task list is both the name of our class here and the name of the object in the data model. So TL task list. If you were to call the object in the data model just task list and call this class out here TL task list, you would have task list here. It's the name of what is stored in the data model, not the class name. So hopefully that wasn't too confusing. So basically the fetch request is just a query. It's a query in object form. So we're not going to be real picky about which lists we get. We actually want all of them. So this will by default get all of our lists. But one other thing we want is to sort them. So we'll say fetch request dot sort descriptors. This needs to be an array, so we'll say ns array with object is kind of our helper method for just making an array with one object in it. And we'll make a new sort descriptor. So here you have ns sort descriptor with key. So this is just the name of the attribute we want to compare on. So we'll use the created attribute, so they'll be in the order that they're created, and then whether or not this should be an ascending sort. Yes. And I seriously guess wrong on that every single time, but I think yes is actually appropriate here. So now we want to execute this fetch request. And we need to do that by calling a method on the manage object context. Now that manage object context is only stored on our app delegate. So the way I do this, and maybe you've got a better way, but the least intrusive way, or the least ugly code, I guess, is to make kind of a helper property here for ns manage object context. And then we will import our app delegate here, because we'll actually be interacting directly with it. So basically this is a read-only property that is just kind of a window into the app delegate's manage object context. That way we can use it pretty easily. We won't actually store it or anything, it's just a basically helper. So we'll implement the actual method here instead of using synthesize for that property. And here we will return sorry if this looks like gibberish, I'll go over it in just a second. So I've typed this a lot because I use this a lot. First we use the UI application class to find the shared application. This is the one instance of our application. It's a singleton. Then we ask for its delegate, which gets our app delegate. We then have to cast that as our app delegate class so that it can know that we have our manage object context method. So we cast it and then we call manage object context, which returns the whole app's manage object context, and which we return from this method. So a little bit of ugly code there, but we can just copy and paste it from now on. And that allows us to pretty easily say self.manageObjectContext instead of having this big gross thing here. So to actually execute the fetch request, we say self.manageObjectContext execute fetch request. And here we just pass it our fetch request, and then here is a property or a argument for an error. And what this actually is, we'll enter nil here because we kind of don't actually care if there's an error because there won't be in this case. But how this actually is supposed to work is you make an NS error object, but you don't actually make it. You can just set it to nil. And then you pass ampersand error in here. This is actually the address of the error object. And if something goes wrong during the process of executing this fetch request, because this method is being passed the address of this error, it'll actually create an error object, populate it with relevant information, and when this finishes executing, that error will be populated. So you can say if error, handle the error. This will really only happen if you're doing things in the background, looking for entity names that don't exist, etc., etc. And most of the time, and I think if you just pass it nil, it affects it, but most of the time this will actually just throw an exception and cause the app to crash, which is a good way for us to debug it. So we don't actually have to use this right now. But in more complex apps, you probably should not just ignore all errors and let it crash. So anyway, once we execute this fetch request, it actually returns an array of basically the result objects. So we can say self.list equals that, and that's it. Self.list equals the results of this fetch request. Once that's happened, we'll just go ahead and tell our table view to reload its data. That'll make sure it's fresh with what's been loaded. All right. So now all this is done. So the big thing to actually make it do anything is to be able to add a task, or a list rather. So let's do that right now. This is also kind of a funny call. Basically, to create an object, we don't just do the typical allocate and initialize methods. We instead use NSEntityDescription, which is sort of the way the manage objects are identified. It's a class that handles a lot of that functionality. It's got a static method called insert new object for entity for name, kind of a kludgy name, but basically we pass in here our entity name, which is TL task list, and then we have to pass it a manage object context to insert this new object into. So again, the helper method helps here. So this right here will cause a new TL task list object to be created and hooked up to our manage object context. That object is returned, so we'll say our new list here is the result of that. So now we've got an object created. We need to set the various properties on it. So we can say new list.created equals we'll use a helper method here. NSDate just makes a new date object with the current date and time in it. So since we'll only ever be marking things as created right now, that's all we really need. Let me turn off time machine so it doesn't create too much lag here. And then we'll want to set its title too. Let's do this. Let's use NSString string with format, and we'll just call it task list, and then we'll fill in the number here. We'll say self.list.count, which will be 1 greater than the current index, so it'll always be, the first one will be 0, the second one will be 1, etc., etc. And then one thing that, gosh, I always forget to do is after you've made all these changes, you have to tell the manage object context to save. And you can see save also takes an error, or the address to an error. Again, this will usually only cause problems if you've totally just written your code wrong, in which case it'll blow up every single time, or if you're doing things in the background that have caused a sort of conflict. So both cases we can kind of ignore here, because if we've made a mistake in our code, it'll crash and we can fix it. And we're not doing anything in the background, we're kind of doing everything serially. So again, not the best practice in a real app, but saves us a little bit of trouble. So this will cause the new list object to be created, but this won't actually get it on the screen for us. So after we've saved it, we can kind of assume by default that this will be the most recent one we've ever made, because we've only ever set the date to be the current date. So we can actually just assume, and in real life maybe you would not make this assumption in case the system clock has changed or something, but for the sake of this we will. So we can just add this new object to our lists. Oops. Because our lists are not mutable, we actually have to call a method on it, array by adding object. This basically just makes a copy of the list with our additional object in it. Alright, so now it's been reflected in our list, but we need to make it reflected in the table too. So we can just say self.tableview reload data, and that actually won't be our final answer, but let's just try it and see what happens so I can show you. And this is actually our first time running it, so hopefully it doesn't just blow to pieces. Okie doke. So we've got 3 lists here. Oh, I guess this is actually... Let's stop this and uninstall this. This is the old version of the task list app, and I don't want to cause any conflicts between the manage object versions. Okay, so here we go. Click the button. It appears to be working, but not really. They're all marked as 0. Now what would be causing that? Let's see. Self.list.count. So the count should be increasing here, and maybe this is a good example of kind of debugging on the fly. And this should cause us to have a higher number. Let's go ahead and just make the change we were going to do and see if that fixes it. I suspect it might have something to do with the individual cells not being updated properly, but that might not be it actually. The big point I wanted to point out is when we were clicking that button, the new lists were just kind of appearing, and it was kind of hard to see exactly what was going on, which is kind of a shame. We don't really like that. Luckily though, because we know exactly where the new list is going to be added, which is to the end of the existing list, we can tell the table view to do a nice little animation because we know exactly where it's going to be inserted. First, before we do that, we need to make an index path that will sort of represent where the cell will be inserted. So we'll call this new index path. We'll say index path for row. This will be self.list.count -1 in section 0. Basically, this is the last index in the array in index path form. We'll need that in a second. I'll show you why. So here's where we can actually cause the animation to happen. We can say self.tableview insert rows at index paths. Here again, we need an array with one object in it. Array with object, new index path. So basically we say insert rows at these index paths. In this case it's just one. And then we give it a row animation, which is just a, I think it's an enumerated type. I use UI table view row animation automatic. And that way it can decide exactly what's most appropriate and I don't have to know what to do. So let's run this and see what happens. If that bug with every one of them still being 0 is still there, we can address that. So if I click this button, you can see it instead just slides at the bottom instead. See? It's really nice animation. We really do like it. So we still do see the problem. Let's get to the bottom of this. And actually, while we're at it, let's uninstall the app so that the data will be cleared and we won't have that big list of zeros. Okay, so the new list.title is task list %d. And we will fill in self.lists.count, and count should be an integer type, NSU integer. I'm actually not sure what's going on here. Let's just keep going. It's not the biggest deal. And if we think of a way to solve it, we will come back to it. Okay, so we've got our way to add lists. Let's also quickly add our way to delete them. Turns out this is actually pretty easy. We've got these boilerplate methods here. The first one, basically we return yes to say that a row can be edited, which in this case means deleted. And then we've got this one here to actually handle the deletion. The only thing we need to add is actually updating our data source, which in this case is our actual managed objects. So here we fill in below the comment, delete the row from the data source. We can just say self.manageObjectContext. It's got a delete object method. And the object we want to delete will be, see we get index path here for which index is going to be deleted. We can just say self.lists object at index, and then we use index path.row. And this is the big one that I always forget. Self.manageObjectContext, you have to do a save after you delete. The saving is actually nice because you can roll back or throw away your changes in certain cases, you know, if you have a big failure or something, but more often than not, it's just something I forget to do. So let's try this and see what happens. Alright, you can see the first one fades in and subsequent ones slide in, and by implementing that can delete, it actually gives us this delete button to click. It looks like we got an error. Maybe that'll lead us to our bug. Alright. This is an internal consistency exception, which basically says that we have deleted a cell, or we've told the table view to, but our actual underlying cells haven't changed. This is the case because we are maintaining a separate array of lists. Even though we've deleted it from the manage object context, our list still has a reference to this object. So what we'll do, kind of the easiest thing to do here, is just to reload our lists. We'll copy this fetch request where we actually pulled out all the lists from the database. And in the case of deleting it here, so after we save it, we'll just go ahead and basically reload our lists. That way when we call delete rows at index paths, our list will have the right number, or our array will have the right number of objects in it. So try this. Actually, they all say 1 now. That's interesting. It's very interesting. I'm really not sure what that bug is. I hope to the viewer it's easy to see, but it's very strange. It's actually, it seems to be changing. I wonder if, yeah, this will be it. When we say self a row at index path, here we go. I'm sure you saw me do this, and I wish you would have yelled at your screen a little bit louder. When we are creating our cell for each list object. Instead of using the index path for selected row, we just need to use index path, which is the parameter that's passed into the function here. So sorry if I just caused you to have a panic attack or something watching me make this mistake, but we actually should use this instead. So hey, good bug fixing. Okay, much better. And you can see it's kind of weird because at this point there's only 4 objects, so our next one will be called floor, but again, this is just a demonstration, so we're not trying to make anything too fancy here. Alright, I'm glad it's working though. So at this point we can create our lists. Now we need to be able to create our tasks. Simple enough, right? So first of all, here in our task list view controller, we kind of need to define the external API that it'll be using or providing. Basically, the only thing it'll need to do is be able to accept a list that will kind of be its display or its object that it's displaying the contents of. So we'll use the class directive here to say that there is a class called TL task list. And then we'll just make a property called list. Synthesize it in here. Apparently Time Machine does not want to stop backing up. Oh, it's stopping the backup. That's useful. Okay, so before we go any further, because we will forget, as in I will forget, let's define our segue. So when we go from list to task list, let's just give that segue a name. We'll call that list to task list segue. Again, this is just kind of a naming scheme I use. I typically only have one segue from one view controller to another, so I can say, blank to blank segue. In certain cases, you may not be able to use that. Obviously, use whatever you feel is appropriate for your own apps. So here, in our list view controller, we want to make sure we set up the list property connection. So we'll implement the prepare for segue. We'll say if segue.identifier is equal to string, and we'll just paste that in there. I copied that in the last screen. Here's where we'll actually hook up passing off the list. So to do that, we'll need to import our task list view controller. So here we'll say basically just pull off our task list view controller from the segue itself. And then say that its list is the list at index, and here is actually where we'll use the code I tried to use before. Self.tableview dot index path for selected row dot row. So this just basically facilitates the handing off of the list from our list view controller to our task list view controller. Alright, we'll do something very similar for the task list view controller, except we don't even need an array of tasks because that's actually contained within the list itself. Go ahead and blow away this init with style. So again, we'll implement the table view methods real quick. Number of sections, 1. Number of rows in section. In this case, it'll be self.list. And actually, we need to import the task list. And we need to import task. self.list.tasks.count. That's how many rows are in the section. And again, it's just one section. I need to return that. Cell for row at index path. This will be task cell. Do something similar, and here's where we will see a problem, and I'll fix it in a second. TL task current task is self.list.tasks. You can see we don't have an object at index. That is because, like I said before, our set of tasks is not ordered. We can kind of fudge that for now by saying all objects. That just basically puts it in an array with any order in it. And I can say object at index, index path.row here. We'll see in a second why this is probably a problem. But we'll go ahead and hook it up anyway. Cell.textLabel.text equals our current task.details. So this will essentially work, but again, you'll see the problem. Add task, it's almost exactly like our previous implementation. Actually, before we do that, let's go ahead and do our boilerplate manage object context. I typically do it in each class that I'm using. And the good news is we can actually just copy and paste it from the other class. Grab it from here. Just copy and paste the whole method from our list view controller. Drop it right in there. That way we can use that in a second. Okay, back to what we were doing. We were on add task. Same exact thing we did before. NS entity description, insert object for entity name. This will be TL task. In manage object context, we'll use self.manage object context that we just created. We'll say, remember, it returns what we just created. Alright, now set the properties on our new task. We'll say new task dot details. Now let's do the same sort of thing, even though we'll be able to set it later. Say, we'll just call it new task. We'll make this a formatted string. Oops. Say self.list.tasks.count. So very similar to last time. We'll say new task.created. Same thing here. Use NSDate, the static date method. And then there's the one new thing. We'll say new task.list equals self.list. And here's the great part about core data. By saying that this task, its list is our current list, we don't actually have to tell the list to add the task. Core data will automatically hook up both. So the list will now be aware of the task is now aware of the list, everything is good. Again, we need to save it. We use the nil for the error again, okay, described before. And now we're actually good, except, again, need to actually cause it to appear. Say self.tableview, insert. We'll need to make a new index path like we did before. And this will be self.list.tasks.count -1, except that needs to be inside and then NS indexed path. Wrong method. We want the row and section version, which is the category defined for table views. In section 0, we will use our helper again. New index path. And again, we'll use the automatic row animation. So, looks like I got my brackets messed up a little bit here. One more on the outside here. Alright, looks good. So at this point it should work, but you'll see pretty quickly what the problem is. You've got our existing list here. Just go into one of them. Alright, perfect. I was hoping it'd behave strangely. Now the problem is, and this is not the same problem we had before, because you can see it was 0, then it was 1 for a while, now it's 6. I don't know if it has anything to do with weighting or not. Maybe. Anyway, completely nonsensical. Oh, and as we scroll off and back on, do they change? Sometimes, yeah. So, absolutely bonkers how it's behaving. This is actually, in my case, a common bug I've run into once or twice. Because we're using this all objects, where is it? In our, right here. This does not guarantee any sort of order. So we have the same cell being used multiple times for multiple, or the same task being used multiple times for multiple cells, and some not being used at all, so it's just a big mess. So let's make a quick way of making this sorted. We'll do that by making a category. We could actually just write it right here into task list. And I'll tell you real quick that the reason I do this is because by making a category on top of task list, it makes it very easy for us to regenerate the, if we make a change here in our data model and we use our create subclass, we can actually run right over the top of our existing files without messing up the code that we've written in addition to it. So we'll just add a new file here. It'll be an Objective-C category. We'll call it customization. And you can totally add these methods into the existing task list class, but just so we can see potentially a more maintainable way. And this will be a category on TL task list. So just hit next, create it. It'll drop it here at the bottom. I'll just pull it up right below so we can see. So now that we've got this category, we'll add our new method here. It'll actually be a property. I'll make it a non-atomic, and it'll be read-only because it's really just sort of a view into the existing tasks. It'll be an array called sorted tasks. And basically, every time we call this, it'll do a new sort. We're not going to cache the results or anything like that, so we'll have to be careful not to call it all the time, but this will basically just sort them and return them. So we'll implement it right here. And here, this hopefully won't be too confusing. We'll say self.tasks dot all objects. So this is an array, but not necessarily an ordered array. Now we can say, let me add the bracket here. We'll call the sorted array using comparator. It'll generate this kind of funny looking token right here. Double click it to automatically fill it, and then add a bracket and a parenthesis. This is called a block. If you're not familiar with it, it's, I guess real quick, just basically a function that will only be used once. It returns, and this syntax is very strange. The caret denotes that it's a block. It returns an NS comparison result, and it takes two arguments, object 1 and object 2, both are IDs. So basically I just need to implement this, and it will call this per object to sort them basically. And what we'll do is really easy because we know they're all tasks. Let's go ahead and import our tasks. We will actually just cast the first object as a task, and then we'll call on it details. Task. Details. So details gives us the string that is basically its name. Then we'll call compare on details, and this is the built-in string method to compare two strings. And we'll need to pass it the other object's details. So we'll do the same thing here. TL task object 2 details. So a little wonky, but actually a very small amount of code that we've written here. I might have done a little too much bracket making here. Details. Right. Fix this. All right. Looks good. We need to return that. All right, and this now we can call sorted task, and it will give us a sorted list of tasks. Again, this happens every time we call this. In real life, you'd probably want to cache this result or something so it wouldn't be so expensive. Because we have a small number of tasks, because we're only calling it once or twice, not a big deal. So here, instead of all objects, we will call, actually instead of tasks entirely, we'll call sorted tasks, except it's not completing because we've imported task list, but we haven't imported our new category. So we'll do task list plus customization. That's the change we have to make here. Now we can have sorted tasks. And this, we should see, works just a little bit better. And as we run it, I realize the mistake I've made. We don't actually want to compare its details. We want to compare the dates it was created at. So switch those details to createds. Run it again. All right. Now, I'm just going to one of these tasks. We've got tons of tasks here. It looks like they're all actually correct now. Create a couple new ones. See they appear at the bottom. Let's make a new list. 0, 1, 2, 3, 4, 5. Looks a lot more organized. Okay, so far so good. Quickly, we'll add in the ability to delete these tasks, very similar to the way we did it before. Uncomment the boilerplate methods here. Same thing, self.manage object context, delete object. Here we'll say self.list.sorted tasks, remember, because we actually have to know its position. We'll say object at index, index path.row. Again, this is exactly like what we did last time, so sorry to bore through it. We'll call save, again, nil for the error argument. And remember, last time we had to actually reload all of our lists. In this case, because we're using the list of tasks directly from the list object, we won't actually have to do anything besides this. Core data will automatically remove the object from the list, will automatically update all the counts and everything, and hopefully I'm not lying to you. Let's see what it does. So swipe, delete, delete, delete. Let's switch to one that has less things in it. So let's delete a bunch of these. And then one easy way we can see if the count is correct is by adding new ones. Yep. Alright, we're actually almost done with the app. Last thing we need to do is be able to edit and save them. This is kind of our last thing we do with manage objects. So jump in the storyboard. So one last thing we need to do is hook up this text field right here so we can actually access its value and set its value. To do that, we'll go into our task detail view controller, go into its implementation file. This can be a sort of hidden property. Make a new property, make it non-atomic and weak because it is something that Interface Builder or the storyboard itself generates. It'll be a IB outlet so we can see it. And it'll be a UI text field, and we'll call it details field because it represents the details. Add our synthesize down here. Alright, and then hook it up in the storyboard before we forget. So drag from the taskbar down here, or the status bar down here. That's the easiest way to do it. Alright, cool, hooked up. Similar to our original, or our task list, you can see where we just were. How we had to pass in a list to this one, we'll need to pass in a task to our task detail. So use our class directive here again. We'll call it TL task. And so we'll just make a new property. It'll be TL task. And we can delete this init with style. Because we use a storyboard, that is never called. I think that's the big reason that's useless. Here we'll synthesize our task. Alright, and again, before we forget, let's hook up the segue too, because that's the one thing we always forget. So this will be task list to task detail segue. This segue will be triggered from the task list. So save it up here. We'll add our prepare for segue method. If segue dot identifier is equal to string, again we'll just kind of paste it in here. Import our task detail view controller. What's going on here? Oh, forgot the two-letter acronym. All right. Alright, so here we will be passing control off to the task detail view controller. So we'll pull it off the segue, and then we will set its task basically. And we will get that from our list.sorted tasks, remember. Object at index, and here is where we'll use that funny self.tableview.index path for selected row.row. Basically the index of the thing selected right now. It's quite a bit of characters, but that's exactly what we want. So that passes off the task properly. Alright, now upon loading, so here in view did load, in our task detail view controller, we'll say self.detailsfield.text equals self.task details. We haven't imported it yet, so import it up here. TL task. Alright, easy enough. And now, here in our save, it's pretty easy. Actually, let's go ahead and add that manage object context property like we always do. This is a read-only property. Okay. We'll just copy and paste that again. Alright, need to import the app delegate too. I mean, the only problem with this is that we do use the app delegate a lot, but it's kind of hard to avoid, so at least it's only the app delegate, I guess. So when we save it, what we want to do is self.task .details, and basically at this point we will just pull the text from that text field, and if it's changed, it's changed. If not, we'll just be overriding the exact same text. Equals self dot details field dot text, and then we'll just save the manage object context because this task is managed by the manage object context. Saving the manage object context itself causes all its connected objects to save. It's kind of weird. It only gets confusing if you have multiple contexts. So anyway, and then we'll do one more thing. We'll tell the navigation controller that kind of encloses this to pop a view controller. This will be animated so that the user can see that, but once we save, we really aren't going to stick around. We want to go back to the previous screen, so we'll do that automatically for the user, so as to not tire their thumbs clicking the back button. Alright, this might actually be ready to go. Alright, jump into one of our task lists here. Bunch of new tasks. Click on one of them. We can see the description got populated automatically because we set the text field. Let's change this to make the app work by clicking the save button. So we've got a problem here. Nothing happened. But I'll tell you what, if we go back, you can see it did update. So I bet you can guess what's wrong. We need to tell the task list view controller to update itself when it gets focus again. That's pretty easy to do, and we actually did it in the last one too, in the last app we made. We'll just implement a view will appear method. Make sure we remember to call super here. I'll pass the same animated parameter. And then we'll just say self.tableView reload data. This happens before the thing is visible, so it doesn't matter if we do fancy animations or not, the user will never see it. And actually, no items will be added or deleted, so it's just text that's changing. So let's actually get kind of a fresh start here. The good news is that deleting these lists will also delete their enclosed items, because there's nothing pointing to things anymore. Which actually, that might not be the case. I might just lied to you. That might be something you have to configure in the data model. It might not be turned on by default. Anyway, we've made a new task list. Remember, we won't be able to edit the names of these. It's just not worth adding the whole extra view controller for it. So we'll make a couple tasks. Change this one to learn to program. And you can see it updated. Great. Adding a new one. The count is correct. We can delete them. Alright. At this point, I think we're ready to go. I think the app is finished. So hopefully this was useful to you. We've kept it under 90 minutes, which is good. Again, this is not really meant to give you a full breadth or full depth of core data, but really just to get your feet wet. With something as complex as core data, there isn't really a good way to learn it all at once. But the way that I found most useful, and the way that I actually learned myself, is to have working code that does something simple and then improve it and fix it and make it more robust from there. So that's really what this tutorial was meant to do. I definitely recommend the core data documentation that Apple provides. I think there's a whole core data programming guide that you can find. all the documentation that Apple gives you is very good. The only thing that's a little bit lacking is the fetch request. There's a specific kind of language you can use in fetch request. That's the only thing I've ever found to be lacking. I definitely recommend it. So check out the documentation. I hope this was helpful, and let me know if you have any questions. All right, thanks for watching.